Now we're going to take a look at number 5. I told your class the other day that you're not going to have to worry about number 3 or 4 on there, and the reason is because you see tangent of 2x and cosine of 4x. We're not going to deal with any multiple angles in there, so you can ignore those. They're not going to be on your quiz coming up. Secondly, though, we're going to be looking at number 5, and you might notice that it looks a little bit more difficult than some of the others due to the fact that it's a longer equation and it's got quadratics along with the trigonometry. It doesn't make it impossible to do, but it does add a couple of layers to the problem that otherwise would not have been there in the other two problems. So, right now, the problem there, and it's 2 sine squared of x minus sine of x minus 1 equals 0. You might be tempted to add 1, but remember this is a quadratic equation, so you want 0 there. And the best way to do this would be to factor. We wouldn't want to really mess with trying to do the quadratic formula here. That wouldn't make too much sense in this case. But two numbers that you can get that multiply to that negative there and everything, I think we'd go with a plus 1 along with the 2 sine of x and factor it to the same as this, minus 1. If that's confusing to you, you might want to take a look at a little tip here. What if your problem was this? Try factoring that and then compare that to what I have factored. So I'm going to erase what I just put up there, but that factoring should work the same way as typical. And we'll see if my scratch out works here, but apparently it doesn't want to. Oh, there it goes. Okay, next we're going to break this up into two pieces like we do with quadratics typically that we have factored, and set each piece equal to 0, because in order for two things that are multiplied together like that to equal 0, one of them has to equal 0. And then I'll get sine by itself here, and I'll get sine by itself here. So the variables have been isolated as one trig function. That's not a negative right there. And that. Now we'll put that 1 over 1 because again it's got that right there. We need a fraction. Going back to memorize your little facts, and this is going to be y over r, and this will also be y over r. So we're going to have a few different things available here, and we might have more than one answer, or more than two answers like we typically do. And the first thing I noticed that the radius on this one is 2. So I'm going to use that and see what I can come up with. I'm going to put this one aside for a second, and I'll come back to it after we've solved the first one. But I do want a radius of 2 for that first example, or the first part of the factored equation, I should say. Okay, radius of 2. I have a y value of -1, so I go down 1 unit because it's y, and then over to the circle. At this point right here, y equals -1, and at this point right here, y equals -1. It might be tempting to try to draw a line straight across there because we connected the dots on if it's cosine or something like that, but this one is sine. In any respect, I'm always going to draw my right triangles so they make a right angle with the x-axis, never the y-axis. In fact, these triangles should only touch the y-axis at the origin, as you can see here. I'm going to label a few of these things now. This would be -1. This would be -1. I drew a radius of 2, and so this has to be the square root of 3. Now I am interested in finding the angle that's across from the 1 in each of these 30, 60, 90 triangles, but in terms of radians, there's my 1, I go across from it, and this little angle right here will be pi over 6, as will this. Now, this angle is the first one I actually come to, and it's a little bit more than half a circle. Half a circle exactly would be pi, but it's a little bit past that, so I'm going to add pi over 6. Common denominator would be 6 here for these two fractions, even though you don't see the first one as a fraction yet. If you have 6 pi's and you add a pi, you'll get 7 pi, which is the red one that you see up there. And the blue one will be next, going all the way around, nearly to a whole circle. If it was a whole circle, I would say 2 pi, but I have to take off that little pi over 6 slice. Again, common denominator, it's going to be 6. when I subtract here, I'll end up with 11 pi over 6. And I'm satisfied that that's 2 of my answers. Now, what I have done, this part of the factoring is what I've just done here. Everything you see here, all from that first equation. And you will notice that there's another one there. But this y value is 1 and the radius is 1. Well, that's going to be a little bit weird. But I need to see another circle then, because obviously this one has a radius of 2. It's not really going to apply to this second equation. By second equation, I mean this. But that's totally valid, just like the first one was. So move this down, give myself a little bit of room to work, and I'll be working with this blue one down here. Now I've got a radius, but it's only 1. So it might look a little smaller. And that made it huge, so we'll undo that. And not having much luck yet. Slow a little bit. Try again. That's a radius of 1. Now obviously that's going to be pretty small looking, but I think it will be okay here. A circle draw. There you go, radius of 1. Next, we go through and we're going to figure out what this is going to look like. Only one spot on that circle has y equal 1. This is the only spot where y equals 1. Since that's the only spot, I'm actually only looking for one angle here, which is going to be like this. It doesn't apply to the 3069 triangle or anything like that because it's not a triangle. You can't draw a triangle to the x-axis there. So I'm looking at that, and we should have known from a while ago that the pi over 2 is what I'm looking at there. 90 degrees is pi over 2. And that's what we're seeing with this second equation right here. But regardless of that, I have 3 answers. You can see 7 pi over 6, 11 pi over 6, and pi over 2.